Good morning, everybody. Welcome to the first edition of Power Hour Expert Mode. Today we're going to do advanced Lua from the Orion's advanced math and logic software function. This will be a fairly advanced, I guess you could say, webinar. So we expect that you've probably had some experience with Lua or something like that. We won't go into a lot of the basics, although we will touch on a few. My name is Jeremy Anderson. I'm the Director of Global Sales Engineering at NovaTech. And with me today to help on this webinar is Sean Ryan.
Morning.
Morning, Sean. We'll be kind of going back and forth doing different parts of this webinar. One of the things about this webinar is we scheduled it for 2 hours, I believe. I made it a large window so we can, have time. It may not take that long. I'm going to guess it probably won't take that long, but I wanted everybody to, be able to block out that time if they wanted to so that you could get as much out of this as you can. We're going to do questions slightly different this time. They're still done the same way if you've attended a Power Hour before. In your GoToWebinar tool bar thing, there's a questions area. You can ask questions. We're not going to answer them on the fly during a lot of this, but we will answer at the end of each module that we talk about. And we'll get into what we're going to cover today in a minute. Then we'll try to answer relevant questions on what we just talked about. But this way we don't kind of break up some of the coding that we're going to show to answer questions. Ask any questions you want. We'll try to answer them, when the time comes. Or at the end, if we have some time left, we can go through other questions. Or if you have something that we didn't cover and you're curious about, then at the end we'll do a little open session potentially and talk about some of those questions. So feel free to ask as many questions as you can, or as you want, I guess, and we'll try to get those answered. And as always, at the end after the webinar, these are recorded, and we do send out a post follow-up email with all of the questions and answers. Along with, we are going to send out a file with all the examples that we do today, with a lot of comments in those examples so that you can, see those and have examples of that sort of thing. Power Hour t-shirts, still doing that. I've kind of fallen behind, so in sending some out recently, but we will get more of them sent out. So what we tend to do is take the top most active people, draw 3 names from that, and I'll contact you via email, and we will get your shirt size and address and ship you a Power Hour t-shirt. So our agenda today, we're going to talk a little bit about Lua optimization, loops, Lua tables, string manipulation, file I/O, command line access, which also includes some OS commands, date and time, libraries, and potentially database access. And we'll get to going through each one of those. For your own use, there's a lot of information on Lua out on the internet. The main location, obviously, is lua.org. There's the Lua manual, and there's the top link there. That's kind of more of an example guide. to find examples, but if you Google how to do X in Lua, you will find lots and lots of material out there as well. So it's a great resource, and it is a heavily used programming language. It is an open source programming language for those of you that have no experience in Lua, and it has really become popular in the last few years in the gaming world with the newish game Roblox. So if any of you have kids that play Roblox, that is coded in Lua, and so there is now a lot more material out there on Lua than there was just a few years ago. So Lua optimization. Let's start there. Rule 1, don't do it. And then rule 2, you see, don't do it yet. Optimization is something you should never start out with necessarily. You kind of have to ask yourself, does your program need to be optimized? And in the vast majority of programming that you would do in the Orion, the answer is no. So it's useful to understand a few best practices that are a little faster in running than other ways to do stuff. And we'll discuss those a little bit as we go along. But in this world, in the automation with Orion and using Lua, most of the time you do not need to worry about optimizing your code. And that tends to be because, one, we don't need things to run extremely, extremely fast, always. And even if we do, writing standard Lua code is very, very fast. And also, you may end up spending more time trying to optimize your code and redoing it and trying to test it to see if it runs, a millisecond faster. So it's just not worth something to take into consideration, really. But there are a few things that we will talk about as we go along that are just the smarter way to do stuff, runs slightly faster, and is really cleaner to do. So the first thing we're going to talk about is loops and iterators, which are the same thing. And we're going to turn that over to Sean, and he's going to show some examples and talk through this section here.
Perfect.
Let me make you the presenter here. There you go. Oh, hey.
Cool. And NCD should be popping up here in a second.
Yep.
Awesome. All right. Well, good morning, everybody. We're going to jump into starting the loops and iterators portion of the presentation. So this should be a kind of a gentle warm-up into our expert session. Hopefully you guys are familiar with the concepts of these already, but we're going to cover the three that are presented within Lua and the NCD programming window. We're going to cover the whiles, repeats, and fors. And so you're going to see up in this section that the bolded text is more of the commands, and then this lighter text is going to be the stuff that you put in there yourself as you're using it. But the basis of this is, starting with the first one, we have the while and then the expression. So this is going to be the condition that is true here. And then while this is true, it's going to go ahead and execute this code until this expression is no longer true. In a kind of an inverse type mentality, we're going to have the repeat function, inverse of the while function, I mean to say. But this is going to repeat a block of code until a condition. And then lastly, we're going to jump into the for expressions. There's actually kind of two different types of this, and we'll get into it in a little bit. But some preliminary notes that we want to go through before I jump into the examples and off this screen is that the conditions, or the values, if you will, of just false and nil are the conditions that test false. But the things that are going to catch you are things such as the number 0. So if you have an integer value of 0, or even an empty string cell in there, those are actually going to test true. So you need to watch for those conditions just so that you don't have an error in your intended code. Return statements, so if you want to pull a value out of this code that you write, it does need to be in the end of it, in the last statement of your block. And then lastly, not commonly used on the Orion platform. We've just struggled to come up with an example of why we would use it. But if you are inside of any of your loops, you can use the break statement that will actually exit the loop regardless of these conditions. It'll actually just jump right out of that loop and continue on with your next block of code. So what we're going to do is we're going to jump into NCD. You'll see I'm already in the advanced math and logic window. I already have a testing timer function created. It's something that runs every second. It's just something that we're going to use for our code block here. And then as a reference, I already have a port set up that actually has all of these different outputs in it. So you'll know, for example, this is going to be a bunch of latched outputs on an Orion IO. So I have output 1 all the way through output 16, of course, going sequentially there. And so what we're going to do is we're just going to jump right into it. We're going to go into the while condition. So if you select this guy, of course, as you guys all know, I'm sure you do have example code blocks in here. So this gives a reference of how to use this function. But we're just going to go ahead and adapt this. So I'm going to write a function essentially that manipulates all 16 of those latched outputs that I just showed on my Orion IO. And so what I might do is just start by following my example below. So I'm just going to reference that first variable. I'm going to call it a local of I, and I'm going to define what that starts as. And I'm going to say I equals 1 because this is actually going to be a placeholder of the number inside of the name of each of those points. Again, I had outputs 1 through 16, and so I'm going to do some concatenation here in a bit. You're going to watch that this 1 is going to reference that output 1 to begin with. So what I'm going to do is I'm going to say while I is less than or equal to 16, basically going for outputs 1 through 16, I want to do something. And so in this case, I'm going to go ahead and do an Orion set point, and we're just going to reference the names of all of those points. So we're going to follow that same syntax that you can. If you wanted to follow along, of course, you could go to Orion and you could go to set point and you could follow the syntax of what you need to follow here. But we're going to go ahead and put in this table, and I'm going to say that name is equal to output. And what I'm doing is I'm actually referencing the names here. So I'm going to say output, but I'm going to stop there. And I'm going to do a concatenation and reference this first variable that I've created, I, so that each time it goes through, it's counting up, basically, 1 through 16. So I'm going to continue that on. And now I'm going to put in, and I'm going to importantly include a space right here, too, just to follow the syntax of these card names. So with that space, I'm going to say at card C, and then from there, that kind of does the basis of what we're going to be referencing in this while loop. And then from there, I'm going to go ahead and say value equals 0. We're going to say online equals true, and we're just going to go ahead and finish up that syntax blocks. So with that, basically, as this goes through, it's going to go ahead and say output 1, output 2, etc. How is it going to do that? Because each time we are going to increment my counter. So every time it runs through, I is going to now equal itself plus 1. And then at this point, it's just saying I need an end for this block here. And that would essentially be a very, very quick way to create a loop that goes through and addresses all 16 of my outputs. And I mentioned that they were latches. And so this is going to be a reset of all of my latch points. Again, I said the while style of loop is going to continue while the supplied condition, this, is true. So as soon as it hits 16, I set my output. Output 16 is now cleared. 16 in the I equals I plus 1 and 17. It's no longer valid, so it's going to go ahead and end and jump out of that function. So that is a quick way of how you can do clears. If you wanted to set, obviously you can set this or adapt this code to be a little bit more dynamic, but that is going to be a quick way of how you can go ahead and run this through. So for now, just even for example, I'm going to go ahead and set it to a 1, and we can go ahead and simulate this code. And you'll notice that the values are all zeros as part of my initial. And as soon as I go ahead and click run, here on my simulation, just boom, it instantly all set to true. Even though this timer is running, just every second, it went through the code just that fast. So if you were to watch this physically on the Orion IO, you would watch all of your outputs just instantly clear or set very, very rapidly. And so these loops are used, again, to go even faster than you would desire within one of these, event timers per se. And it's one of the quickest way to go through these codes or to manipulate your conditions. So with that, unless we've got any questions, we're going to jump on to the next flavor. As we said, the repeat function, if we jump into the example here, let's go ahead and end this simulation. If we go into the repeat, as I said, it's almost an inverse mentality of the function we just did. So what we're going to go ahead and do is, again, you can reference the code down here if you like. You'll see it's very, very similar to what we had just done. And so if we go ahead and use some of these same things we started with, if we were to jump into the repeat function, we're going to go ahead and do a almost exact same idea. So I'm just going to borrow that code and use that once more. And so we're going to say orion.setPoint here, but to start that function, we are going to say repeat. And based off the example, the repeat is just going to do something here. We're going to go ahead and follow that same idea of incrementing our counts each time. But now with this style, we need to do the until. So we're going to go ahead and say until, and I'm going to say greater than 1. We're going to get rid of our old stuff here, and then we are good. Until let's go ahead and say I equals or greater than 1. So the reason we did this is, again, as we mentioned earlier, this function is going to loop until this condition is true. This is more of a limit function. Another note that's really important is that this until is still kind of considered part of this entire block. So it's going to run through, and this code is going to be referenced each little time. So it's going to run through this, reference this, and then loop back and go ahead and repeat through. And so it's going to go until this condition is true. So in the same fashion as we did before, if we start with a count of I equals 1, it's going to go through, output 1, etc., come through, increment it each time. And then, oh, I'm sorry, I meant to put 16 here. Anyhow, that's probably a confusing bit. So it's going to reference that value, increment it, and by the time it finally is incremented to 16, let's even go to the portion before 15. By 15 comes through, output 15 is set to a 1. It's going to increment. It's going to be 16. And then it will run through again and finally get that last value. So that is how we can do the repeat function. Jeremy, any questions so far, any of these guys, or should we keep going on to the for loops?
Nothing that I'm going to answer quite yet. I will talk about, we've been a few questions about the simulate button, and I will talk about that in just a few minutes.
Gotcha. Okay. Yeah, so I'm going to skip the simulate on this one just to save a little time, since you guys probably can guess what happened as we did on the last one. And then the last section that we're going to do is we're going to cover some of the for loops. So we're going to go ahead and wipe this section out and kind of start from scratch again. The for loop, there are two different types, as we kind of mentioned. We have a numerical based. As we go through this, it'll make a little bit more sense. And then we have a generic that kind of uses, non-number based. And so if we click back to our PowerPoint here, the way that the for is going to work is that you say, for, and then we're going to put a range, a value here, and then we're going to put again, kind of the limit, if you will, in this next expression block. And then lastly, one thing to state is that these square brackets are kind of the optional fields that you can put in for some of this syntax. And the last one is going to be the step. So if you omit this section here, it's always going to reference to a step of just a 1, an integer value of 1 here. So for this range, hopefully this will make more sense in the next section. It's going to go ahead and do a block of code, and then it will just go ahead and end after these ranges are completed. So if we jump back into NCD, we're going to reference the exact same mentality as we did, and we're going to go ahead and do that same clear or set our latches as we did. So what we're going to do is, again, with this code here, you can reference it down in the bottom. But what we're going to do is we are going to call for, and then we're going to say a number, and we're going to say 1 through 16, again, referencing the outputs 1 through 16. And then we want to do something. And you'll notice I've omitted the step, and so it's just defaulting to that count of 1 for me. And so now what we're going to do is that same code. We're going to do the Orion.setPoint. I guess I should have saved this from before, but go ahead and put this in again. We'll do name equals output. Concatenate it with that. We'll put in our space, or I'm sorry, we're going to go ahead and put in our number there, referencing up here for the counter. Concatenate that, put in our space. We'll do output at card C. Value equals, we'll do a 1 in the case if we wanted to set them all, and then we're going to say online equals true, and then we'll go ahead and close that statement. And then of course we need an end for that function. And so this one gets a little bit cleaner in my mind. It's a little bit more preferred or optimized, I guess. It's a little easier to read what it's doing, but in the essence of this, what we're going to do is this value number is going to start at a value of 1, and it's going to range or increment by a step of 1 up to 16. And each time this loop goes through, it'll come back and increment that count of the number. And so again, as you guys I'm sure can guess, it'll run through here. It'll go from output 1 to 2 to 3 all the way up to 16, and it's going to set all of those latch points to a 1. Again, if you wanted to clear them all, you could put that to a 0, but that is a very quick way of going through there and utilizing some of these loop type functions. I think that kind of wraps it up. Unless you want to add anything else in here, Jeremy, I think this covers the numerical form of how to do the for loops. I alluded to what's going to be the generic style, and I think Jeremy's going to touch on that when we jump into some of the tables.
Yep, that's correct. So I'm going to answer one or two questions here. The simulator that you're seeing us use has not been released yet. We are using beta NCD software. We are moving. Currently, there is a Lewis simulator that is installed with NCD under your start and in NovaTech NCD. There's a simulator, and it works fairly well. You have to open the NCD file in there, and you can simulate advanced math and logic with no problems there. We are moving that simulator into NCD, like you see what you saw Sean do and what you'll see us do throughout this discussion, this webinar today. And we are actually running a very simplified or a very stripped down version of the Orion process inside of NCD when we do this simulation, when the simulator runs. This way, it really gives you a nice, knowledge of how it's going to really run in the Orion. So we are still doing some tweaks to it, things like that. So it's not been released in out to the public yet. So that's why nobody that's on the webinar sees that simulate button. But that will be coming on the next release of NCD, which will be sometime relatively summerish, I think. So we do have betas. Betas are tested really well, but they are betas. So, we have some customers that want to use an NCD beta at times to add a feature that we've added to NCD that they needed or something like that, or a fix. So we can actually, do that. But sometimes the things we're doing in the betas breaks something else. So that's up to you if you want to try a beta just for playing around with the simulator or things like that. We did have a question on, can these functions be run not as a timer basically, but be called? And yes, a function can be called by a point changing or another function, and you'll see that throughout this webinar of how that's done. So we'll definitely go that. So there's a question for you, Sean. Can you do for loops with specific numbers? For number equals 1, 2, 1, 2, 4, 16, do. And, will it do the numbers, only the numbers specified? And Sean, you can answer it, I can. But it's really a from to.
Yeah, it's more of a set range when I have not actually tried to put in a dynamic step. So I don't know if it's possible.
It is more, in this instance that you see here, it is a range. You're doing, the first number is from this number to this. And it's always from to. Now, there could be a way to make it do specific numbers. You can make it count by numbers. I believe, if I remember right, and I'd have to go back and check, I believe you can make it count by 2s or 3s, stuff like that.
So I don't know if you're still referencing, but like, for example, what I just did on the screen now is I made it count by a count of 2 each time.
Correct.
And so this would do every other input, for instance. But one thing to note, too, is that even though so the question was, can we do numbers perhaps 1, 2, 4, 16? Well, this count might just be a linear range, but you can also take this range like that, and then down in here, you can also reference that same number, and then you could set this to something, and you could square that number, you could manipulate that, and then use that in your next line of code if you needed to as well. So there is, even though that this is a linear or stepped count, you can manipulate it in this next line of code if you need to. So that's one way to get around it.
Correct. All right. Okay, so I'm going to go ahead and switch back to me so we can go into the next topic here.
Good.
And you should be seeing, Lua tables. So this will be this would be the longer portion of this discussion, I think, today. Tables are extremely useful in Lua. They are, unlike other programming languages, Lua only has tables as a container. Right? The only container in Lua is a table. But tables can be used to do things like arrays or metatables or, things that you could normally do with a different container in, say, Python or some other language. You do everything using a table. It's just how you use it. They have no fixed size, and they can grow when needed. They can shrink. They can, they're variable, if you will. And they can be indexed with numbers or strings. And so what I want to do is go into a couple examples of some, I wouldn't call them super complex tables, but some ideas of tables of how to do certain things. We're not going to go into the basics of tables, but we will, get into some pretty good examples, I believe, here. All right. So the first thing I'm going to do, and this will go back to the question you asked about creating a function that runs not like a timer, is I'm going to create a new event function, and I'm going to call this one, let's say, table build. And I'm going to create that, and I'm going to leave it as a data change. So now I'm going to go ahead and give myself some room here, and I'm going to create a table in here. So the basic, table would be something like this. That creates the variable test table as a table, and then we could move on. But that's, and then you can put information in there. We're not going to do basic tables because I believe everybody should understand the basics of tables. What I'm going to do is a much more interesting example. So I'm going to first start out, and I want to put a few, some data into this table. And the first couple things I'm going to do, I'm going to put using strings as the keys. So remember, in a table, you have a key and then the value associated with that key. That key can be an integer, it can be a string, it can be a mix of things. In this case, I'm going to use some strings, and I'm going to say, oops, if I type correctly, I'm going to do IP address, and I'm going to, give an IP address. Each key and each key and value pair needs to be separated with a comma in order for it to go into the table correctly. So I'm going to do another string, username equals, and then I'm just going to do NovaTech, and then I'm going to do password equals NovaTech. Oops, forgot my comma there. And if I closed this table, that would create a table that had those three key value pairs. That's useful, but what I want to show is how we can also put tables inside of tables. And so what I'm going to do here is I'm going to actually create another table inside of this table. So I'm going to call this one point names. And the reason I'm creating a table here is because I want to hold a bunch of, say, point names for a device in an area that I can reference separately, but I can reference all of them. And you'll see how that works. So I'm going to, again, create another table. And in that table, I'm going to put some point names. And I actually have some already built in here. these binary inputs. I'm going to put 6 of these or so, give or take. So I'm going to do this, and remember to always put a comma because we are, again, in a table. And now all we're doing is putting the value. We're not assigning a key, and that's because by default, if you do not assign a key is a integer key is assigned starting at 1. In Lua, integer keys start at 1. Some languages, they start at 0, but Lua, they start at 1. So this is key 1, and I'm going to go ahead and do key 2. Oops, so I hit the right buttons. And key 3, and key 4. Maybe that's all I need to do. I'll do one more. And key 5. All right, so I've now got this table, but I do need to close this table out. So I'm going to go ahead and close that table. So now I have open table, close table. And because I actually don't need this comma here because it's the end of the table, but because I'm coming in through here, I've got this table here, I've got this table here, closed, and line 8. Oh, it doesn't see that. That's fine for now. So what I want to do here now, keep hitting the wrong button. I'm going to clean this up, just kind of move some of this back. Just to line it all up. I don't need that comma. And let's just make sure that I've done everything correctly here. I've got my table declared, and inside my table, I'm setting key IP address to an IP address. I'm setting key username to NovaTech, password to NovaTech. I'm going to actually stay with my convention of capitalized. And then I have another one here, and I have each of my binary inputs listed here. Then I have my closing of that table and my closing of that table, which is the big table right there. And now what I want to do, look at that. I see the error. I missed that I had an error there, and because again, I missed a comma. The commas will get you, at least they get me every time. I constantly forget to separate my keys with commas, as you can see. So you'll see me do that probably a lot today. So what I want to do is just something real simple here, just to show. I'm going to do an Orion print statement. And I want to print the IP address. So you have to call and find that key in the table. So the way you do that is you list the table. So we called this test table, right? Table. And you put a dot, and then you put the key that you want to access. So IP address. Oh, I definitely misspelled address up here, didn't I? And I will also want to print out the, let's do the username. How about that one? Test table dot username. So now I have no errors, as you can see. I'm just going to go ahead and close this up some for neatness. I'm going to need to run this somehow. So again, this kind of goes back into what we talked about earlier. with calling these. I have some predefined points that I created earlier. I'm going to have this table run point, and I'm going to tie it to table build. So when this point changes, dead man here, when this point changes, it's going to call this function and run this. So I'm going to go ahead and save my program. I'm going to hit simulate. And again, I know you guys do not have the simulate, but I'm going to talk through some of the features of simulate so that when it comes out, you'll be super excited because it is very, if you programmed in other languages, we're really rebuilding the simulator to act like a lot of simulators out there for different programming languages. So I've started the simulator. I'm going to open what's called the SPY list. This allows me to put points in here that I can force on and off easily. All right, and I'm going to view my diagnostic output. Since I'm printing to my diagnostics, you can print to log and it would come out the log out input. But as you can see here, when I started the simulator, it started the Orion and logic is running. And I'm going to play the logic, and I forgot I need to drag this up into here. And now I can force this point. And I'm just going to force it to a 1. And you can see it printed the IP address that we put in the table and the username. And yes, you can, I saw a quick question come in, and I will answer this one right now just so it's there. We do have stepping functions in this simulator, so if you end up wanting to step through your code, you will be able to do that. So I'm going to go ahead and stop the simulator, and I want to do a little bit more now. Now in this table, and this is where we'll kind of talk a little bit on the iterating a table with the sort of what we call a generic for loop. Sean did talk about the fact that there are, he obviously went through the while loop, the repeat until, and the for loop. And I mentioned at the beginning, we'll talk about a few things that are optimal or best practice. The for loop is your best practice kind of loop. Especially for table stuff. Iterating tables or doing most anything, you'll see almost always a for loop being used. So I'm going to use what would be considered a generic for loop, if you will. So I'm going to do a for, and I'm going to do I equals 1. So I want to start at index 1. And I want to go to, and what I guess I should say this first, is what I want to do is print the contents of this table line by line. So I could, if I knew the table was, 1, 2, 3, 4, 5, there's 5 keys, I could say 1 to 5. And that would work perfectly. But what I want to do is be able to print this table no matter what size it ends up being. So if you needed to come back later and add another point to this, you don't want to have to go and find anywhere you're looping through that table to do stuff and have to change that, 1 to 5 or 1 to 8 or whatever it may be. So what I'm going to do is I'm going to go to the size of the table. So I'm going to go from 1, from the very first key, to the end, or to the size of the table. So there is an operator called this operator here. That's the size of, and now I need to do the table. Now, you cannot just do point names because that is a table inside of a table. So what you have to do is say the table with the key point names. So we'll do test table. So it goes into the test table, and it looks at the key point names. So I'm saying for the integer from 1 to the size of this table, do, and then I'm going to go ahead and do a print. And print diagnostic, and I'm going to print test table dot point names, and then I need to print each one. So the way I say the different integer keys is I put a bracket here. I'm going to go ahead and say I, because that way every time I counts up, it will print integer, at key 1, key 2, key 3, and so on. I'm going to close that. And then I need to do an end for the for statement. And I see there's no errors. So what we're expecting this to do is to print out the IP address, print out the username, and then print out each one of these points. So I'll go ahead and save this. I'll simulate. There's my spy list automatically. Since I was using it, it comes back up and it saves what's in that you've already put in the spy list. You don't always have to keep dragging it, the point back up in there. Go ahead and look at my diagnostic output. I'm going to force that value, and we should see it iterate that internal table. So this is, this isn't a super complex table by any means, but this is a nice way of showing that you can use keys that are strings. You can use, keys that are strings and put strings in them. You can use keys that are strings, and we could put integers in them. And we can put tables into a table, and we can print, those tables can just have integers as their keys, all that kind of mixed up sort of stuff. Before I move on to doing something different with these tables, Sean, anything that has not been answered or?
No, I've been trying to go through the questions that come in, so I think we're good.
Okay. All right. So this is great, right? So we have a table here, but what use is this table if you want to use it for a bunch of different, say, devices or different whatever? You want to use versions of this table. So one of the things that is very useful is creating I guess you could maybe call it a template table. You could call it a generic, table. A lot of people, if you've done object-oriented programming, I think it's called classes sometimes. They do, but there are no classes in Lua. Lua is not an object-oriented language, but you can do some features of object-oriented languages in Lua. So what we're going to do is we are going to step through this table and change it so that it's generic, and then call this table and put data in it and change that data each time. So what we're going to do first is we're going to keep it, still a function table build here. But what we need to now do is we're going to have to change a lot of stuff here. All right. So first thing we want to do is we need to put variables in place for all of these pieces that need to change in the table. So that will be one big change we're going to make. What we have to do before we do that is decide how is that data coming into the table so that we know kind of how to set up our variables. So what I want to do is create another table, and we're going to just throw it in the default start function just because, but it could be another function that gets called that creates a table, and then we're going to use this to read from another table. So let's talk about that. I'm going to create a table called info, equals, I'm going to declare that a table, and then I want to put data into that. So what I'm going to do is do info brackets, first key in that is going to be another table. And in that table, I'm going to put the data that I want to pass into here. So I'm going to have, let's say, user name. Now I'm using different, even though it's username and username, I'm using a small u here. So now that is a different variable. Don't forget that Lua is case sensitive, and so things like username and username are two different variables, which is what we want. So I'm going to say username equals NovaTech. Separate it by a comma again because we're in a table. Password, I'm just going to do shorthand there, equals NovaTech. I'm going to do the IP address, but I'm just going to call it, in this case, host equals 100. And then I'm going to have the device name because we need to know the device name. And the reason we need that is because these points have a device name right after them, and that could change. So we need to be able to have something to put the device name in there. So I'm going to say device name equals, and in this case, let's call it Orion IO. And then I'm going to close that table. And then I want to do another one. So I'm just going to copy this here. And I'm going to put this at index 2. And maybe I'll change the password or the username to NovaTech 1, password to pass. We're just called pass. New IP address. And a different device name maybe. So basically I've created a table called info, and inside of that table I have put a table at each of these two indexes. And now I know what my variables that I'm going to be using down here are: username, password, host, device name. Right? So now what I need to do is go ahead and build a new table that when this moves through, it creates a new table each time with a name to that table. So what I want to do is I'm going to call this table, and I'm going to have an index for the table, and it's going to be the device name. I'm going to call it test table index this, index device name, and we'll put information in there. So I need to go, actually, sorry, I'm forgetting one step that I want to do first. Because I need to run through this table to create everything over and over for however much, is up here, I need to do a for loop. So I'm going to do a for, and I'm going to have two variables, and I'm just going to call them index and info. You can call them I and V, K and V. You can name them anything you want. And I'm going to do in, and then I'm going to use the command or the operator I pairs. I pairs is integer pairs. There are two commands that exist. There's one called pairs, and there's one called iPairs. iPairs is for integers only. So it will only accept integers into this command. And that's what we're working with. If you look at that table back here, we're looking at integers for the keys. And then I need to say what table, info, and then I'm going to do what I'm going to do here. So what I'm going to do is then have my test table, and I need to say I want the what am I doing here? Info table dot, and I want the device name to call it that. So we called it device name. So now that's the key it's going to create, and inside test table at key, in this case, the first one, Orion IO, it will put all this information. And now we'll make all this information generic. So instead of having a string here, we're going to go info dot username. Nope, host. And then here, instead of a string, we'll do info dot username. The same going on and on. So we'll do info dot, what did we call this one, password? And now we get into this table here, and we need to change part of this here. So what we're going to do is we're going to concatenate the info dot device name. We're going to do that for each one of these. So I'm just going to copy it. Oops. And do that.
Sorry, capital I on there, right?
Nope, it's actually a lowercase I. So that's a good question. Because I'm doing this index here, is, from the index number for the number of index numbers, info
right.
is that. So I'm actually using this variable and from this big table. So I've created another. So I just used a lower I. It's actually passing this data into this variable here at each index. So it is little I in this case. All right, so now I need to come in and I want to print this test table. But now when I do the test table, of course, there are multiple instances, or in the test table, there are multiple keys. So I need to tell it, yes, I want the key at info dot device name. And the same thing on down through everything. So you have to tell it what key. Test table again, we have to know which one. And again here. Right. So I forgot my end for the this for loop right here. We don't have an end for it right now, so I need to do that. So now you see I have my end there. I have my end for this one. I have my end for the function. So now I have this entire table. And what it will do is when we start, it's going to build this table with all this information in it. And then when I run this table build, it will build as many instances of a different table, or one table with many different keys as are listed up in here. So if that makes sense, hopefully. Go ahead and we're going to simulate. And we're going to hit play. Watch the diagnostic output. So when I run this, it should print out this information and then this information. Let's run that. unless I've broke something. I know what I broke. So, me and simulate, I know exactly what I broke. I know what I broke, but I want to show you how to know, using the new simulator, how you can figure out what's kind of wrong. The new simulator, since it runs a Orion process, the log output, when I try to do this, will tell you where your errors are, or at least try, right? So here it's telling me the table build could not be called on line 24, which attempt to index a nil value of test table. So the table doesn't actually exist. Unlike the last example where I just made test table into a, be defined as a table, here I'm saying test table this key as if that table had already existed. And I never said that table exists. So what I have to do outside of this for loop is declare test table as a table. So I'll just do a local test table equals, and it's a table. So now I've said test table is a table. Now for all this information at this keys, put that into the table test table. So that one can get you. And let's do a simulate again. Let's run it. Let's go here, force this point, force value, and here we go. So it's printing out those points. And you can see it jumps through. So this is useful because now you never have to touch necessarily this part of the table again. And if you wanted to add more, devices or something in that case, you could just come into here. We can add next index and change up the information, and you can go on and on. So this, you don't have to go in and make multiple instances of this table. You don't have to, change things in this table. It's like a template. So this is kind of where I want to stop at tables for now, because we do have a lot more to get through, and I see we're already past the 1 hour point. Sean, any questions that I need to go over on tables?
No, I think I've answered most of them. We just had one question that came in earlier. It says, is there a limit on the number of entries for a table? And I think that would just be more of a memory limitation, really. Yeah,
and you can, no, there's no limit. Tables are, there's no predefined size, and they can grow as big as you want them. We created tables with, as many entries as you want. So.
And then one other thing I'll ask too is we had a question that's what's going to happen to the existing or older logic simulator when the newer versions of NCD comes out? I think, are we dropping that out of the new versions going forward?
Good question. I don't know. It still exists in my beta, but I honestly couldn't tell you for sure. So I think we'll probably end up keeping it because there are people that still use Orion 5Rs and need a way to simulate probably outside of NCD maybe. I'm not sure, but that one we can answer in the follow-up email.
Okay.
All right, so there's tables. I just want to save that. And let's talk about string manipulation. String manipulation, there's a couple ones I want to talk about. There's, as you can see, these are the four I want to talk about today. String gsub, that replaces a pattern that you search for with something else. And so we'll do some examples of each of these. String find finds the pattern that you say from a string. So you tell it, hey, here's a string, find this in that string, and it returns the starting and the end points of that pattern. And then we have string substitute, which is, or not substitute, sorry, substring. String sub returns a substring of a string, starting at whatever position here and going to this position, J. If there is no J, it returns the substring from I to the end of the string. And then string format allows you to format a string, and there's some good examples that we'll go into coming up. So let me jump back into NCD. All right. So I'm just going to keep everything here and just move on. So what I want to do first is a string G sub. So I'm going to create let's go and create an event real quick. We'll call this one, that's a good name for it, I think. Created it, there it is. Now what I want to do is, in this case, I want to, with the idea of what this example is going to show is taking whatever point name calls this function, and I want to turn that into another point name. In this case, a logic point name. So for those of you that don't know this, in the main portion of the program here, if you put a variable here, and we use point name. Oops, if I type right. When this function is called by a point, it will pass that point name into this variable. And then you can use that in the function. So now you can know what point called the function. Very useful. Actually, we use it a lot in Lua for manipulating point names and not needing to create a new function for each, let's say you have 10 points that are calling this function at any given time, not having to write 10 functions, writing a single function, pass the point name in, do something with that point name, and then a different one calls it. So that's extremely useful. So what I want to do is I'm just going to show this, and I'm going to do a print diagnostic of the point name so you can see that. It's just an example. And then what I want to do is I'm going to get rid of, so actually let's jump into here. I'm going to have this point binary input. I'm going to have these 3 points be the ones that call this point name. Or sorry, call this function string G sub. So what I want to do is first I'm going to change these, which are binary input 01 at Orion IO, to some logic points that I have here, and I just did one of them, binary input 01 underscore Orion IO, which would be the point name at logic with it. So if I, just so you can see what that point name really looks like, that's what the point name looks like. So I want to convert that other point name into this. So I'm going to use a variable, let's call it temp1, just as a placeholder to hold some manipulation of that point name. I'm going to use the string dot gsub, and I'm going to put the point name variable, and I'm going to look for the pattern. So I'm going to say the pattern, in this case, I want space at Orion IO, comma, And then I want to replace the space at Orion IO. So if you go back and look at that, I want to replace space at Orion IO with nothing. I just want to get rid of it. So in this case, I'm just going to get rid of it. And I'm going to close that. And that will put, now what it should put is just binary input 01 into temp1. And we'll verify that as we go, but just by throwing in some print statements. All right. Then what I want to do is I would like to get rid of the, where am I thinking? I want to do another variable, that's right, sorry, temp2 equals string sorry. Sometimes my brain stops working for a second. I'm going to take the point name, and I also want to just get, I want this right here. I want to have this so I can move it and have it stored in a variable. So I'm going to take temp1, and I'm going to concatenate the space at symbol. So I want the binary input 1 and the space at to out of the point name, and then I want to get rid of that. So what I'm basically doing is isolating the device name in this case, right? And so I'll go ahead and print that so we can see it. And then I'm just going to create a new point. I'm going to create that new point by doing, call it point, let's say, equals, and I'm going to say temp1, which would be binary input 01. I'm going to concatenate that with an underscore. I'm going to concatenate that with temp2, which would just be the Orion IO. I'm going to concatenate that with space at logic. So basically, I'm creating a new point that would say binary input 01 underscore Orion IO at logic. And we'll go ahead and do a print diagnostic here. Point. Now we see we have no errors. Let's go ahead and save this so I don't mess up. And let's simulate it so you can see what it does. We'll go ahead and hit play. I'm going to go ahead and drag in these two in here. We'll go ahead and watch our output. So if I run binary input 1, should see by the point. There we stripped it out. There we got that. We built a new point out of it. Same thing if I do binary input 2. So this is a useful, sorry, scrolls. This is a useful command that is used quite a bit by us at NovaTech for manipulating point names, manipulating other strings, and that sort. Okay, let's go into string find. Okay. We're going to make another event. Let's call it string find. And we'll make it a data change event as well. Now what I want to do again is I'm going to pass the point name in here. So I can do some manipulation as well. I do want to bring up something real quick. If I create a function, and this is for Lua as it stands now with all of your 3.36 and non-beta versions, function test, let's say, and I do end. And I want to then make it an event. I can just do test, and it creates it, it finds it, and it knows it's there. If I did this first and put point name or any variable in there, and then came over here and created a new event test, it creates a new one because it can't find just these plain function tests, so it thinks it needs to create a new one because I had a variable here. So it's just to know that it will do that. And now you actually do have two functions named the same, and you will have a problem. So just understand that if you're going to make it a data, an event, go ahead and do that first, or at least realize that when you do that, it could create another one, and it will create it usually at the very bottom of the program. So you may need to go delete that if you've already written that function and it has a variable name. So just so you know, and get rid of that and we'll delete it. It's not an event, and we'll get back into here. All right. So I'm going to do a local variable here that we're going to call string start string. And then end string. So if you recall, the string find returns, the string find returns the start point and the end point in integers of what I'm looking for. And I'll show you that. So I'm going to just go ahead and continue on here and say equals string find. Point name, I'm looking in the point name as my string, and I want to find where the space at symbol is located. So I want to know where in that point is, what's the start of the space and what's the end for those two characters in the point name. And then I'm going to go ahead and let's print that so you can see what that'll look like. We'll print, let's do something, so string found between, let's put some quotes. So we'll say string found between, concatenate that with the, helps if I spell start too. Art. Okay. Start string, concatenate, and then maybe and concatenate end string. All right, so I'll print out the string was found between this point and this point. All right, so we'll end up in that. What I want to do now is figure out what is the point name, the actual device name, sorry. So I can actually just, now we're going to use the string substring. So I want to look at a substring of the point name. And now that I know the start and end point of this in the point name, I'll be able to know where to start looking for the substring I'm looking for. So I'm going to go ahead and do another local, let's say device name equals string.sub. And I'm going to look at the point name and string.sub. I want to start looking at the end of this, but not at the end because the end is the at symbol. So I'm going to do the end string location plus 1. So now what it's going to do, it's going to grab the point name. It's going to start at the end of the string up here, plus 1, and then put whatever's left into this variable D name. And if I wanted it to only go for a couple characters, I could then have where it's going to stop looking. But in this case, I know I want to look till the end of the point name or the end of the string. So I don't put a stop point. This is the start point, and I could put a comma and put the stop point as well. And then let's do an Orion, print diagnostic again, and we're going to print D name. Okay, so no errors, simulate that. Diagnostic output, play, and I need, oh, you know what I didn't do? Some way to run that I don't think I put in there, did I? Do outputs. This is what I want to do. This way you can see this is string find, all these. And why I want to do this is because these are differing lengths of point names. So you can see how we'll be able to, by knowing the start and end of a certain area, we can get the device name out of there quite easily. So again, simulate. I need these up here so I can force them. That. All right, so I'm going to force this breaker control, force value. It's found that at what we're looking for between 18 and 19, and it got the rest of the string. This is a slightly different. Between 19 and 20, it found it, and it gave that back. And here is between 16 and 17, and it gave back the device name. So a quick, easy way to find the device name. But of course, that's not quick enough or easy enough, in my opinion, if you're looking just for the device name. This is super useful for finding pieces and parts of a strings and getting substrings out of that of all kinds. But let's say you just need the point name of a device. There's a much easier way to do that, and that would be using the string match. So let's do no function string match point name. What am I doing on time? Oof. All right, so let me go make an event, which I should have done first. All right. So now what we're going to do is do a local D name. Let's call it equals, I'm going to do a string match. Now, you notice in here we're not listing it as an available command. It is. That's just something that needs to be fixed. That. Point name. And then what I'm going to do is I want to match the @ symbol, right? And then I want everything after that to come back. So I'm going to do a dot, what's called dot, star. This is a special operator, a pattern matching. So there is pattern matching in Lua. And so basically what I'm saying is, in this variable, look for that and give me everything after it. That's what this means. So now I'm going to just do a real basic Orion print diagnostic again. we're going to say, what did I call this? Dev name. Dev name. And save that. And go ahead and simulate. And, oh wait, again, yeah, I did not, oh yeah, no, I need to change, sorry. I'm going to change one of these to string match, there. Since I already have them up in there, so the idea will be I'm going to run this one, and it just returned it right away. So it's a quicker way if that's all you're looking for is the device name or something after, it's a quick way to do a match. One more thing in the strings, maybe we'll move on. This won't take very long, but I'll just type up a quick example and talk to you about it. We won't run it to simulation, is the string format. So I'll just show you string format is a way to format strings. And so we'll just do a real quick one. Function string, call it format. So string format is a command. And so what I'm going to do is I'm going to set a number equal to 10 and just do a local. And what I want to do is change this number to hexadecimal in this case. So I'll have another one, hex num equals string dot format. And I'm going to take, now this one's a little interesting. You first, instead of the string, you first put the command or the operator, or whatever you want to call, I forget what they're exactly called, but I'm going to, this in the case of going to hex, it's X for hex. And then I'm going to put num, what did I call it? Num, yep. And that would then if I hit hex num, that would turn that into a hex number. I did another one. Actually, we don't need to do it. You can change them just so we can make it quicker. You don't need to change. You can change them to octal. You can, change strings to binaries or all kinds of things. So in this case, this would change it to hex. But for the sake of time, we'll just go ahead and move on. I think we're running a little behind, and I do want to get into some of the file I/O. I have about 25 minutes or so. So let's cruise on through file I/O. File I/O, we have some I/O opens, I/O close, I/O read, and I/O writes. This is how you can open a file, create a file, open a file that exists on the Orion, add stuff to that file, see the size of that file, all kinds of stuff like that. So let's jump back into here. We'll call this one, let's go ahead and make an event, file manip. Let's call it that for file manipulation. I'm going to, again, do the point name, which is an easy. Ooh. All right. So what I first want to do is I'm going to define a location for the file. So I'm going to call it file loc equals. Now in this case, since I'm just running this in the simulator, I'm going to define a location on my computer. Whereas if you were in the Orion, you would, define a location in the Orion's file system. So I'm going to do C slash now users Jeremy Henderson documents in CD, and I'm going to look for or create the file called file.txt. Then what I'm going to do is open or create that file depending on if it's there. So I'm going to do an io.open that file location. And what I want to do, there are operators associated with this. There's read, write, and append, and some versions of those. But we're going to append this file so that we could add to it if we need to. And what this A will do is if the file exists, it will append the file at the bottom, whatever you put in the next time. If the file does not exist, it will create that file, and then it will be an appendable file. And all of them will create a file, all the operators, the read, the write, actually the read won't, but the write will, and the append will, if the file does not already exist. You don't need to go create that file. You do need to have the location of the file, if you're going to have a specific directory in the Orion, that directory already needs to be there. Or you can make a directory with some OS commands, and I did see this come up, and I meant to bring that up. Yes, the slashes actually matter. In this case, you have to use, for Windows at least, in this case, you have to use these this style of slash, because the other direction is what's the word I'm looking for? Sean, you know. Escape. Yep, there it is. I couldn't think of the word. That's an escape character in Lua. So yes, you have to use this, and it works just fine. So what I want to do is I'm going to do a local string, and I want to, basically what I want to do is I'm going to do a string format that we talked about. And I'm going to take that point name, actually, in a minute. And what I want to do is I'm going to create a space in my string. So that is space, a colon. And then I'm going to have, again, a space and a carriage return. So these are telling how to format the string. I'm going to use the OS date command to get the current date. And then I'm going to print the point name. So what this basically will do, it will create a string that has the date and then a space with a colon, and then the point name that called it, and then it will move to the next line. I'm going to write to that file that we opened. So when I opened it, it put the file into file. Now I'm just using shorthand to say file write, that string. I also want to just, for fun, get the file size. So file size equals, and then again we have a file seek will seek a portion of that file, and I just want to seek from the beginning to the end of the file. So it will tell me how big that file is, and then I want to do a Orion.print diagnostic of file size is and file size. And then I need to close that file. So file close. And what did I do? 85. Yeah. Forgot to close that out. And then what did I do at 92? Oh, forgot to do that. So there we go. We have, now I need something to run this against. So I'm going to just run it against, I've got one here called file IO run that I already created. I'll have that run. And what I want to do here is I'm going to open up an NCD folder here. I'll bring that back over in a second. So you can see right now, you can see there's no file in there. And then I'm going to go ahead and simulate. No, there it goes. I'm going to go ahead and bring this into here so I can use it. Going to run this. And I did something. Oh, I didn't start the simulator. I started it, but I didn't have it running. Sorry. There we go. File size is 39, which is 39 bytes. We come in here. It created that file.txt. If I open that, you can see what it did. The date and time. There's that colon with a space. And now, since that's an appendable document, if I run that one again, or a different one that would be tied to it, you see it's growing. I come back, open it. So it's a way you can write, in and out of files inside of an Orion. You do have to be cautious. You don't want to write into system files and things like that, but this is good for storing data. The file IO is very useful in that sense. All right, Sean, we got a little bit. Let's jump to command line stuff. We're definitely going to run out of time today, and I'm sorry about that. 2 hours thought would be enough, but go ahead, Sean. I will turn it over to you.
Okay.
And here you go.
Cool. Should be seeing the same thing. Is it up?
Yep.
Cool. All right, so we're going to jump into some of the OS dot something type commands we're going to see over the next few slides. And so as Jeremy said, a little short on time, so we're going to try and do this in a rush style mode. But we're going to cover some of the command line access tools here. So the first one is going to be the os.execute command. You'll see you got some brackets and then whatever syntax you want to put in. But basically, this kind of simulates and allows the Lua to act as if you were into the Linux kernel itself. So, or the Linux kernel of the Orion itself, I should say. And so this allows you to do direct manipulations of that system. So you would just put in, as if you were in the console itself, whatever commands you want. Now the downside to this command is that you don't get anything back from this as far as being able to pull things back into Lua and reference them. So if you want to do that, we use the program open command. Notice it's IO rather than the OS, so apologize there. But what this does is this opens up I'm going to just call it a little virtual program in the background, and this actually returns a directory. But this allows you to manipulate commands, put in syntax as you like, and then read the response back from the system, or the echo, if you want to think of it that way. And so the common application there is going to be create a variable as we've done here, do the IO program open, and then that same syntax as if you were doing it up in the OS execute. And then this variable that's created is basically the response back from the kernel. And so as Jeremy kind of showed on the last few examples, you can create another variable and then actually do a read from that variable you just created, and then using this handle, that's going to read basically all of the response or the entirety of it. And so what you can do is, like a quick example of the OS execute, is if I return back up into here, I'm going to do an example of manipulations of some of the Ethernet ports, or the physical Ethernet ports on the Orion. So I can do still simulating apparently. So if I go into my default start function, so we'll say like on the Orion process boot or restart, if you will, I can do an OS execute and create this command. Inside of my text brackets here, I can go ahead and write, again, as if I was in the direct Linux kernel. So I could do an ifconfig, I could pick an Ethernet interface like this, and I could say down. So every time the Orion boots, even though you could do it in the web GUI and whatnot of the Orion, this is just going to ensure that that ETH1 Ethernet port is always down. Now, in the logic outputs, to show where I'm going here, I have a point that I created, local maintenance enable. So this would be a point you could map back to your SCADA system or whatnot. And so if we come into my events, I'm going to go ahead and I've got my testing one. We're just going to call this port control. We're going to create that. We're going to do keep it as a data change style event as Jeremy did, and that logic point, we're going to map that back to port control. And so if we come through here, I'm just going to do a nice little conditional statement that says if, and I'm going to do an Orion.get point, and we're going to go ahead and put that point in there. So we're going to say if that point value is equal to a 1, meaning perhaps SCADA sent a 1 value to this control, then we're going to go ahead and do a OS execute. Just going to reuse that point. And we're going to change that to an up. And so basically, if the Orion receives a control from your SCADA system, perhaps a maintenance technician could then plug into the system through that port. As soon as they're done and they want to verify it, they could get a command back from that system, and we will do the exact same thing except leave it as down, and then we have a way for SCADA to now manipulate those Ethernet ports directly and control physical Ethernet ports remotely, in essence. So that's kind of a quick way of how to use OS execute. Notice again, it doesn't get anything back into the system, but that's just a quick way to quickly issue controls that you don't need to read anything for. Another one that we had, I'm just going to do a little quick copy and paste for the sake of time here as an example. If you wanted to do another block of code, here's an OS execute. For example, my local Orion that I have is on this network, but this one actually goes in and manipulates the IP or the routing tables, if you will, and basically just creates a loopback. So if you wanted to do any local testing on your Orion and whatnot, basically anything sent out of the Orion that was intended to go to anything on the 10.10.10 network here would just be routed back to itself, and you could create multiple ports and kind of do a all-in-one testing inside of just your single Orion box with this style of commands. So the next one that we had is going into the program open, and that one's going to be for, again, calling things back that you want to reference. So if I create some little space here, just so we know where we're at, we'll go back into this section. We're going to go ahead and do a section for that. So I'm just going to start defining some variables here, and we are going to do the program open, and again with those brackets, and now we can go ahead and start our text here. And so what we're going to do is an example of how to do checksums or build hashes, if you will, of files that might be on your Orion. So in this case, again, as if I was typing directly into the Linux kernel itself, I'm going to go ahead and do a MD5 sum. And then I'm going to put in a directory of Orions, and then Lua dot let's do power hour.ncd. So this would be a example, even though obviously we're not on the physical Orion itself, but this would do a quick checksum of my NCD file that would have been stored inside the directory. So if you go in and browse to the ETC Orion folder, that's where you're going to find all of your program files that you put in there. So if I put some brackets around that, we are good. And again, that's just executing the command. It's not calling it back yet. So in the next case, we're going to go ahead and do a local like this. And now we're going to do a mread, as Jeremy showed a little bit, just doing a quick read of what was the response back in that m variable there. And then with this, we're going to do that special handle of saying, I want to bring back everything. And then we're just going to go ahead and close that out. And so S is now going to have the response back of that command up here. Now the next thing we're going to do is kind of showing what Jeremy had with the string subs again. We're going to just do another one. We're going to do string.sub. Now the reason we're doing this is this command actually brings back more than just the hash. There's extra stuff after that. And so what we're going to do is we're going to bring in just S, and we only want from character 1 to 32 since it's going to be those 32 numbers for that hash. So now T is going to be just my hash, and at this point I could do an Orion.print diagnostic of just straight T. And if this function were to run, we're not going to simulate it just for the sake of time, but it would spit out just that 32 character hash from the MD5 sum of that file. So obviously you could rinse and repeat this. You could run this against an entire directory worth of files if you wanted to modify and use it as like a little security type check, send this value back into SCADA or keep it retentive just to know that your files are in fact the files you intended and that they haven't been modified, or alerts you to modifications and whatnot, and so on and so forth. Jeremy, feel free to interrupt me if there's questions, but for sake of time, I'm just going to keep cruising here.
Yep, go ahead.
Awesome. All right, so yeah, that was the quick example of how to do the program open command. If we jump back into NCD, I'm just going to do a quick little copy and paste again. I don't thank you all for being willing to keep going, if you would, but I'll try to be quick and trying to be thorough at the same time. So if we were to go, and granted, I'm not creating the proper events for this, but here's just another example of something that you might use to use that program open command again. So what's going to happen here is we're creating a function that if you feed in an IP address, what we're doing is we're creating, there's going to be some string matching as we go through in here. But what's going to happen is we're creating a local good string. And so that's just going to be the response back that we're hoping to get. It says one packet transmitted, one received. And now what we're going to do is we're going to create another variable F, and this is going to be that program open again. And we're sending this raw syntax, if you will, into the Linux environment. And basically it's saying we want to ping, and just a single ping, that's that parameter there for the count, and then a wait of 2 seconds back, just to give it a little bit of a window there to respond. And so the response that we're hoping to get back is now going to be stored and read in local F. And what we're doing is a string match. We're looking to that response. So we've got L here, and we are looking for one packets transmitted, and then looking for their stuff, because there might be, multiple messages that come back. And so these are just kind of wild cards, if you will. Just these can be any characters here. And so with that match, then we say if that match of J is equivalent to good up here, so that gives us our Boolean operator of a 1. If it's true, then we're going to go ahead and do a print diagnostic of ping success. Otherwise, if we get a 0 or something else, it's going to say ping fail. And so this is a way to do a quick ping check in the perspective of from the Orion to other devices, and you can use those and bring those back and obviously use those within the Orion. So obviously you have COM fail points and whatnot that are built in as you create your DMP ports or whatever else inside the Orion, but you can extrapolate this and use it for basically non-SCADA type devices. So if you wanted to do ping checks of other things that are in there on the network, if you wanted to check workstations or network hardware or what have you, you can use this as a way to bring those messages back, and then of course bring device or create things like device health points and other things like that. So that's one way, again, to bring in messages using that program open syntax there. So the next one that we're going to do is we're going to jump into kind of related to what Jeremy did, but these are now Lua specific commands. And so I apologize for the little bit of a busy screen here, but there's two that are built in that can be used in multiple ways. And so the first one is going to be the os.remove command, and then obviously you put in the file here, and that is basically just going to delete given files that you put in for this directory here. Pretty straightforward, not going to show an example of this one, but the os.rename file, as we feed into here, you give the existing file name and then the new name that you want to do it. So pretty straightforward. But if you take it a step further, and this is also going to apply to the os.remove command, you can put in a full directory. And so you'll notice in this case, obviously I shorthanded it for this, but you can put in the full Linux or even the Windows directory for the simulator, for example, of where you want the files, and you can move it. Now you could also keep this same name, and that would move it from one directory into another one. So this can be used not only as just a rename, like for example, you don't have to put the directory if they're going to stay in the same thing. You can do a quick rename, or you can use it as a move type command, even though it is still the os.rename, and actually move it from one directory to the next. So one example that we might use if we jump back in here for some of the syntax is that we could do again, pretending we're live on the Orion itself, we could do an orion.rename, and what are we going to rename? We're going to go ahead and put in the brackets like this, and before we jump into that, we're going to create a local variable of count. And then in here, we're just going to pretend some code, something that's creating log files, getting data for us. We're storing it to files, and maybe we want to do some date codes or something. But again, local count could be date, it could be file counts, it could be numbers, whatever you want it to be. But what we're going to do is we're going to pretend as if we were in the Orion directory of var.logs, which is where you're going to find a lot of the information in there anyway. And then I'm going to pretend that we had some directories here inside of the current, and we're going to call this the running log.txt file here. And so we're going to go ahead and take that file, and then we are actually going to do a move after putting the comma in there, and we're going to put in the new directory. So we're going to go ahead and do that same var/logs. But now we're going to put it in like an archive or a history folder, and I'm going to call this log, and now we're going to break out that concatenation, and we're going to reference our count or date or whatever else we want in here. And then we're going to concatenate that again back with our txt, put that in there, and that will, in short, do a move of a running log that you have, one that you keep creating and whatnot, and then move it and store it based off whatever variables you have here. So that's a, what am I missing? It looks like, oh, wow. Go ahead and do this, os.rename. And so that will be a quick way of moving and manipulating some of the files without using necessarily some of those IO style commands that Jeremy showed previously. So again, these are unique just to the Lua environment here. Moving on, unless Jeremy got anything to add or questions?
No, you can keep going.
Cool. So the next one, again, apologize for a little bit of a busy slide, but these are two important commands, again, unique to the Linux environment here, or I'm sorry, the Lua environment. These are going to be the os.date and os.time commands. Now, these, in essence, work almost in inverse of one another, and the tables that I've put in here on the right are actually some of the syntax that we can utilize that I'm going to try and show throughout some of our examples here. If you call the os.date just by itself, just in brackets, it's going to print out the equivalent of doing this %C, which if you reference over here, date and time, it's going to basically spit out this style of raw text output. And of course, if you do it just in brackets, it's going to give you the current time local to the Orion itself, and then what's referred to as its own locale, or basically its own time zone. So you'll notice up above that if we manipulate that format a little bit, we can use these different syntax pieces and start to change how the output of that's going to look. To make it one step more complicated, you can also put in the star T symbol here, and rather than spitting out just a nice raw text string, it's actually going to produce a table. Thankfully, Jeremy explained tables for us already, but it's going to spit out basically the year, the month, the day, and so on, as you guys can read. Now, also, if you put in front of all that, if you use the exclamation mark there, that's going to ignore the local time zone of your box or device, and it's actually going to return all of that formatted into UTC. So you can combine the exclamation mark with the star T and use that, and so on and so forth. But just as like the first example that we have here, if you were to print this out using the OS date, you can also use past times or references, and this is going to allude a little bit into the OS time. So just accept this as it is for a second, but this is basically a count in seconds, and it's going to format all of this into the given date style. For example, %X, you reference over here, it's giving me just the calendar date, essentially. Now, hopefully this didn't make any sense at all before, and it will now. OS time is giving basically an absolute, if you call it just by itself, is going to give an absolute time reference. Now, the epoch here, again, a lot of new terms, hopefully, for some people. The epoch is referenced basically is the start of time in the computer land for Unix or Linux of January 1st, 1970, and notice that's straight at midnight. This is the computer beginning of time reference, if you will. So if you call OS time, this is going to give you, with just brackets, nothing else included, that is going to give you a absolute, or like I should say, relative time in seconds to this count. So you can use that as references as you go through your code. You can call OS time, call it again later, subtract one from the other, and that will give you a duration time or a count. And there is actually another function, os.diff time, that you can use for that. But otherwise, if you're calling this function with the table, it says you have to provide at least the year, the month, and the day as you feed into that, and it will give you that relative count again from this date. And if you skip any of the after fields, for example, the hour, the minutes, the seconds, etc., everything is going to default to noon. So do be aware that this little offset's going to exist, because if you skip it, it goes to noon, whereas the epoch is referenced to midnight, so there is a potential for a 12-hour difference in there. So if you start seeing that, that would explain why. But again, for the sake of time, I'm going to skip some of the demos on the OS time. We're going to do just the OS date. But for example, if I were to do a print log and see the output as I feed these in, again, notice with that offset, so we're going to say from the start of time, 1970, January 1st, hour 0. If I were to plug this into my local Orion, being that I'm here in Colorado in the mountain time zone, it is actually going to account for that offset, because I am in the Mountain Standard Time Zone, has a -7 offset from UTC, and so it's actually going to say that we have a duration already of 25,200 seconds. So if you start to see some offsets, hopefully that explains a little bit why, but do keep that in mind as you use that in some of your own programming. But if we jump back over to the NCD environment, we're going to show a few little OS dates, manipulations, and times. So I am going to see if I can get this to show still with that little table over on the right-hand side. So this makes a little bit of sense as we go through here. Let's see. We'll go ahead and get this stuff out of here for now. So what we're going to do is a few little examples of the OS date. So if we do the Orion.print diagnostic, and we go ahead and just do the os.date command, that would print out the current time. So I'm sure you guys already know what that's going to look like. It's just going to print out stuff in this format, obviously, of the time now. So I can manipulate that a little bit. Let's say I wanted just straight counts that make a little bit more sense for logs. Let's say I wanted it in the year, month, day, hour, minute, second format. Kind of following some of the fault log style syntax you might see from relays and whatnot. What we're going to go ahead and do is actually put in that syntax. So I'm just going to reference my table over on the right. So if I wanted the full year, I'm going to go ahead and do a %y following down here. Obviously, if I only wanted the two-digit year, I could have done the lowercase y, but in this case, the capitalization does matter. And then I'm just going to do a month. We have just the M for that. We have the %day here for the day of the month. And then we're going to jump in and we're going to use the time. So now capital H %M for minute. And then we're going to do a %S, I believe, for second. And this should print out the current time. So if I go ahead and do a save of this guy and we do a simulate here and we run it, since this testing timer is running every second for me anyhow, you'll see in the logs that every second it is spitting out basically just a running counter of the time and date. So you can use that and manipulate it as you need to for getting the format that you like. Now the next thing that you can do is you can use more than just these handles. You can actually start to put in extra stuff. You can say the year is, and then with that syntax, we save it, simulate it, run it, and go to our diagnostic output. I can put in my own little variable strings, and of course any of these extra little handles, it will fill in the blanks for you, again referencing that OS date. So a little bit of power to this command basically for string building, if you will. And I think, just for time's sake, that kind of wraps up the, unless you want me to, or any questions that came in on that stuff, Jeremy. Otherwise, I think we'll hand it back over to you.
Yep, that's fine. We'll come on back over. Let me make sure I show my screen here. So you should be seeing my screen.
Yep.
And let me just jump through to where you are. So libraries. I want to talk just quickly about Lua libraries. We use them a decent amount in when we do stuff for customers. So we call it a Lua library. It's not an official library that you would find on, built for Lua. So Lua, if you go and searched Lua libraries, there are libraries that are inherent to Lua, like the string library. There's some that people have written that are used all over the place, like the date library. But basically what a library is, it's a program in Lua that's kept separate from the main program. So what I want to show is, let's see here. It's just the idea of what a library can be. So if I go back to my NCD file and we and in my simulate here. So if we go back up to here and talk about this table again real quick, I could put this table function here into a separate document, and I could call it table.lua. And I can put that in the Orion and not have it in the main Lua program for NCD. So it wouldn't show up here. And then what I could do is do a command in here that is called require. So I could say require, and then you just give it the name of the library that you created. So if we said this was a table. And what that will do, and again, this wouldn't be here, is it would link the main program here to the library program. And the usefulness of libraries in a lot of what we do is to protect a part of a program that you don't want to get messed up accidentally. It's kind of how I look at it. That code that you never want to change or you don't want anybody accidentally changing can be a separate file. You still load it into the Orion on the Files tab. It's a .lua program, file, but it doesn't open up in NCD. So when you go to open NCD, you wouldn't have all that code there. So an example, if I show one here, let me see, I've got a library that if you look here, this is a long library with all kinds of functions in it. And this library is actually called from here. We acquire this library. And then this is all that's seen in NCD, is these three functions that are run by different points and pass that data into this long library here that does all sorts of stuff. And this way, this library is very generic in a sense that it doesn't ever need to be changed. You're able to kind of keep it separate where no one accidentally gets in there and makes a mistake in it and breaks whatever that library is doing. So it's something we use a lot for big code, and it's something you should consider using if you're writing a lot of code in Lua that you don't want it to get messed up. You can have multiple libraries. In some cases, we have 2, 3, 4 libraries sitting there in the Orion that pieces of the main program call into to do a specific function. And there are libraries out on the internet that may or may not work for you, but one of them is the date library, which people use and we use as well. I don't know if I have that one up here right now. I do not, but it's a date one that does some date manipulation that we use. So some customers will have that, but it's definitely very useful to have. Database access, we're going to probably do at some point another expert mode power hour on accessing the Postgres database, the AAR database from Lua. It's not terribly hard. It is a lot to learn, and you have to understand the structure of the database and the table structures and all of that to understand how to write the queries and that sort of thing. So just know from this that you can do that. You can access the Postgres database, and you can pull data out of it using queries. You can write data into the database if you want. You can manipulate that data. There's a bunch of stuff you can do because it is a SQL type database. So we will go over that at some point when we'll have another one to do that and go over how that's all structured and how you can do that. But that's a super powerful feature that we implement for some customers. And I think for a lot of you, it could be useful if you're using the AAR database and you want to get data out of that and then do something to that data, or because of that data, run some other, functions or whatnot. I do want to I'm going to look through some questions that are out there still. And then, we're right near the end. So I thank you for the ones of you that have stayed. There's 66 people still on here. And if you have other questions right now, we'd gladly go through those. But I'm trying to just see here. I think we answered most of the questions. There was one earlier about local variables. You don't always have to declare a variable as a local variable, but what I will say, and I meant to mention this all throughout, and I failed to mention it, but I did talk to you about Lua optimization. There is one thing that you can always do and should do if you're able to, and that's use local variables for everything. Unless you absolutely need to use a global variable, you should not. Local variables are much faster to access than global variables in Lua. And when I say much faster, we're talking, not seconds and seconds or anything like that, but they are much faster. So, those are things that people look at and don't realize how much certain little things can do. But let's say you were going to run, and I can just give you an example, and I think where am I here? So I can type it out. Let's say I was just going to do the global variable minimum equals math dot minimum. If I ran that and I looked at how long it would take to run that command, it would, that code would take, let's say approximately 0.7 seconds. If I declared it as a local, that code would take about 0.4 seconds. So especially math stuff, because of the way Lua uses local and global variables and the way it does its underneath, Lua is written in C, so the way it does its actual computation underneath, local variables are much faster, and you should use local variables as much as possible. So that's just something to bring up. But you don't have to, and you really, it's not the end of the world if you don't, and there will be times that you can't. There will be times you need a variable to be all over the place in multiple functions, then you need it to be a global variable. That's fine. But if you can, make sure you use local variables. Another question, whoa, where did my questions go? Sorry about that. They popped back into the thing. Another question that I wanted to go is do we have a repository of useful functions? We do. And what we will be sending out, we've sent this out before, so a lot of you have this already, but because we did have a Lua webinar, sometime in the summer. I don't remember when, but we'll send out a zip file that has a lot of examples of different things you can do in Lua, stuff that's been written by us. It's mainly written by me or one of the sales engineers as examples of how to do certain things. Some of it you'll see that we use here. So that will be in the follow-up email along with all the examples from today, so that you have those and you can use that. We want you to be able to not have to search around the internet to find how to do certain things that we do all the time. That way you have examples. So that will absolutely be coming out, when the follow-up email comes out. And that follow-up email usually comes out about a week after, a little bit before a week after, usually by, early next week, give or take. It might be a little later, just depends. We have a lot to do on this one to send out that email, but that'll have a link to the video that we've done here, and it'll also have a whole lot of some documents we'll send as well that you can use. So one more question, and I don't really know the answer, but I'm going to read the question, is can we make our own table structure in the Postgres database? I'm not sure. Honestly, I don't know, but that's something when we get to a webinar on interfacing with the Postgres database, I'll know that by then, that's for sure. So, and then we'll be able to answer that question more. I think all of the other questions were answered. So I'm seeing, give you guys just a few minutes if there's any more questions that you have. And while I'm waiting just to see, I do want to remind everybody that there is our new Power support community, power.novatechautomation.com. I know a lot of you are signed up for it already. This is where all the webinars are found, documentation, application notes for both Orion and Bytronics. So that is there. So, please, if you haven't registered for it, absolutely register. I do all the registrations come through me. So I have to manually enable you. So sometimes I'm not super fast at it. So if you don't get an email right away, I will get to it. Just some days are slower than others for me. So, also, we'll the sales engineering booking site. It's booking.novatechautomation.com. You can come in and book time with any of the sales engineering team. If you see here, you would click. There's actually for both of our groups in NovaTech, process and then power. So you can see Bytronics and Orion. Click on that. It'll show you, you can have a drop-down list. Each person listed here, when you select that person, it'll show their availability for any given day. And you can book 30 minutes at a time. Whoa, where did that all go? Sorry about that. It'll book, you can book 30 minutes of time with a sales engineer. We'll do a team meeting. If you can't use Teams, we'll reach out to you and we can do a GoToMeeting or something like that. And we can go over, help you out and stuff that you need a little help with. So we have all of us here, and for those of you in Latin America, we have Carlos is in Latin America. So if you want to do your session in Spanish, absolutely. Brian Geringer is does Bytronics for. We can all do some Bytronics stuff, but if you have a very complicated task or question in Bytronics, Brian is the best one to book because he can go into great depth for you. So with that, I don't see any more questions. So I want to thank everybody for joining this webinar today. We definitely appreciate it, and thank you for spending the extra time, even past our what we said we would take. I hope everybody got something out of this, and in 2 weeks we'll be having a webinar on Orion DNP. It'll be not an expert mode, but it'll go into detail of the Orion, setting up DNP in the Orion, including things like DNP secure authentication and that sort of stuff. So hopefully some of you have already registered. If not, you'll see registration links coming out again in the near future. So I appreciate everything you guys, hanging out with us, and I hope you have a great rest of your week.
Awesome. Thank you.
Thank you.